Hi, good evening. So, welcome to the session on edge computing and AI. Basically, I'm the whole agenda of this session is to understand where are we, what is the basics of. Let's try to understand the basics of edge computing. At the same time, we'll see what is the current relationship we are having with edge computing and AI, and how the future would look like. So, myself, Abhinandan, I'm an associate professor at Department of Computer Science in NIE, Mysuru. So, as you know, right, so there is a proliferation of devices with respect to the IoTs and mobile phones and all those things, right? A decade back, we never imagined, right, the kind of content what we are watching on our mobiles. We never expected them I expected them in the last decade, right? So if you see, right, annually the kind of data that we are generating is around 175 zettabytes. Probably by 2025, it is estimated that we will have 175 zettabytes of data. So, and one zettabyte is nothing but is equivalent to 10 to the power of 12 GB, right? So think about it. So how much data we are generating? And the next question is where we are generating this much of data. And one thing everyone knows without introduction now, the cloud computing has become a standard. So what we are doing is that we are generating a huge humongous data, and it is the cloud that is helping us to process this data. So what is cloud? So we all know, right? We all know that we do have that instances. Whatever the work we want to do, typically before the cloud, we would develop an application and then deploy it on server, and most of those machines are within our premise, right? So if I'm an enterprise, I would actually I would actually have my own data center where I would actually store everything, right? So typically the issue was there were typically two issues. One, my demand was not uniform, right? Sometimes my demand is really huge, and sometimes it is pretty low. So what I have to do is I have to do the provisioning, and generally we do the over provisioning, and this would have resulted in a resource wastage when my demand was less, right? And other thing is that the depreciation cost of hardware is every year it reduces, right? So for example, because of advancement in the hardware, right? For example, if you take a mobile phone, what I was paying for iPhone 12 would be less compared to the iPhone 13, right? So because every new product would have better feature. So basically, when we deploy the server today, right? So its value reduces next year. So these are the two typical problems we enterprises were actually facing. So what cloud did, it enabled the on-demand provisioning of those resources. So, and we have already, everyone know that we have different types of service models. One is the application. Typical example is our Gmail, right? And then we have an pass, which is very popular among the which is very popular like Salesforce and all those things. So Salesforce is a SaaS, sorry. And then Google has its own pass, and then we have a Amazon instances, which basically gives you the ability to deploy your applications on the virtual machines, where the virtual machines are vanilla virtual machines, right? So this we call it as cloud, and the ability the cloud gives us is then on-demand provisioning. So when we have a cloud and we have data processing, right? So why we need edge? This is the answer. The number of data, right? We have seen that the data has been generated exponentially year and year. And the one thing, if you see this graph, right? If you see there's a consistent reduction in the data we are creating and storing at the endpoint. So we are reducing it, but at the cloud and edge, we are going to increase. Year on year, we are increasing the data, right? So the data is now generated and created and stored at the core and the edge rather than the endpoint. That's a trend that we are seeing. So what is edge computing? Why we need edge computing? See, edge complements the cloud. If you see here, right? So at the end of the day, I have my core servers or data centers, and then I have my edges. So the idea is, if I actually do the processing every time at the cloud, let us say that I'm at India, and then my cloud servers are at US, right? Whatever, for every request that I get for processing, right? If I send it to the data center at US, obviously it would actually congest the network. Typically, our network is still in IPv4, right? And as you know, networking is there is no guaranteed delivery. It is a best ever service, right? So the networking, it would increase the networking load, and the moment it would breach the cloud data center, and it would get processed and coming, and once it comes back as a reply, right? So there is a considerable latency. So this latency is fine for normal applications, right? If I'm actually, for example, if I have a YouTube, I'm watching YouTube on my mobile, or Netflix basically. So what happens is that if my content, right, if I when I'm watching the video, if I see a lot of jitters, right, most of the time the experience would not be good, right? So what people try to do is, okay, instead of sending everything to the cloud, right, let us do the processing near the user location, so that we get better user experience. So that's the motivation of edge computing. And if you see this one, right, so so we have a cloud, and then we have an edge consists of the devices, and now we have an end devices that's connected to the edge, right? Now we have actually any processing capability on the devices, we call it as fog. So that's a terminology, but it is an tiered architecture, multi-tiered architecture, where we have a cloud at the core, and then edge at the edge of the network. So this is how the edge computing looks like. So this is a one reference implementation that we are actually finding in the we are following in the industry, and this is actually defined by the edge consortium. So basically, you have you have a site plan, which is nothing but the physical site where the solutions are going to deploy, and you have an edge layer, and then the cloud layer. Okay, so in the edge layer, what we have is that the edge manager and then orchestrators, which actually does a lot of things. Like, for example, it's a, if you can think it as a miniature of what the cloud would do in its data centers. Okay, so whatever we are actually the roadmap that what we are seeing in future, right? Edge is a more a miniature. We do have a couple of edge devices which does a lot of processing, and now we are slowly giving more intelligence to the edge. So what happens is that you have the computing or network KPIs. You have a computing resource, network resource, storage resource. The storage, typically we want to keep the some data, especially the privacy, right? So GPDR is becoming is already a norm in Europe. So any company which is going to process the European citizens' data should keep its data only in Europe. Okay, so that's an in a GPDR in nutshell. So in order to implement those kind of stricter privacy laws, edge comes to our rescue, and this is where we keep our storage, and then anything that we have, we send it to the cloud, and there we have typical applications and cloud services. So basically, you will have a unified service framework. What that means, see, any service what we deployed on the edge, right? So it is like a first level support. So typically when we talk about when we bring any product, right? So what we do in case of any issues, we first go and talk with the first level call center, and if they are able to answer it, and we are done. Otherwise, we move it to the second level. So this is the same thing. So when we talk about the unified service framework, we the services that what we deployed at the edge should seamlessly work along the edge and cloud side, right? So the application that is running on my mobile phone, for instance, should not know that it is actually like streamed from an edge location or cloud location. So that kind of unified service framework we were talking about, right? And then we have the management services, data lifecycle, and security services. These are the part of the edge computing reference architecture. So the next question is, okay, we know, right? See, at any point of time, edge computing cannot replace the cloud. So edge complements the cloud. So then what are my scenarios for applying for in cloud and edge? So basically, when we talk about the cloud, it is applicable to global policies, and then the edge computer is more or less local. And the network pressure, what we see in a typical code, is huge because the data center is connected across the all the location, right, across the locations, and hence you would see a lot of load, network load. Compared to the edge, we have connections only with a set of the devices. And then if you take the real time, so there is an high possibility, and then in the edge, you will find the low latency. So basically, if I am actually using only cloud, the two distance cloud with respect to the real-time processing, I would expect higher latency. And edge, if I go with the edge, it is a lower latency because most of the things are done at the edge. So this is the main motivation for us to the edge. And then when we generally, what is the typical scenarios? When we require large scale centralized processing, we use cloud, and then small scale intelligence analysis you can do away with your edge. So this is one of the typical architecture that we can see in the industry 4 or manufacturing domain with respect to the edge computing. See, as you know, right, the cloud computing is applied across domains. So you can see the cloud is in high performance computing, it is in AI workloads, it is used for gene sequencing, you name it, we have cloud, because the cloud is the one nowadays which is actually handling the data processing part. It gives you it enables your data processing across heterogeneous systems, right? So the same thing happens with the edge also, right? So all the things, right, if you see here, right, so there are devices, heterogeneous devices, they all have their sensors, and they generate the data, and we send those data to the edge layer where we do the limited analytics, right? So, and then it is more or less the first level or second level of edge processing, and there is a possibility, there are some reference architectures where we have multiple layers within the edge. For example, if you look into NFV, where they talk about for OpenNFV and then OpenStack, in fact, they talk about small, medium, large edge, right? So you can have a multi-tier architecture within the edge itself. And then whatever the decision that we have made, right, we can actually send directly to the device, or and then we can actually send the everything to the cloud, where the cloud would take the improve the model. And one example would be our Google Google keyboards, right? So whatever we new words we write, right, so it would actually trained and it would actually send to the Google, and we call it some federated learning. And federated learning was possible because of edge computing. So the global model is developed at the data centers, so where it is processed at the data centers, and you have an edge layer where you actually implement a small model. So this is one example where we have actually edge for IoT. So as I told you earlier, we have a sensors, and then we have an internet gateways where you actually have the sensors to get the data, and then you have data acquisition systems which take those sensor data and then aggregate it and send it to the edge for processing. And finally, you do the analytics at the edge, and then and then you complete the first level of processing or decision making, and finally you send it to the data centers or cloud. So the whole idea is, when you have an edge, right, you can do a lot of things, a lot of minimal things here in the edge, and then you can actually pass. You need not wait for the cloud for everything. For example, if we so autonomous vehicles or self-driving cars, right? So it would think about it. So if the car wants to make a decision whether to take right or left, and if it wants to wait for cloud, it would have been a disaster, right? So in a road, it would result in a traffic jam, right? So the self-driving car. So what happens is that people actually, that's the reason, are going to are building, giving the intelligence back to the devices, where you aggregate it, you do a lot of things for yourself and and give it to the cloud. The same thing that what we see in a typical political scenario in our country, right? We have a federal systems, right? The states have some kind of autonomy, and they do their they have their we have a state government and the central government, and a lot of the local issues are handled by the state government, and then the central government is actually responsible for the sending for the policies across the nation, right? The same thing, if you can think of, cloud is my central government, and my edge is my state government. So this helped me to scale, especially when we are moving talking about the distributed machine learning and then the future edge. So these are the simple examples of edge devices. Like the left one, this one is a Jetson Nano board, where you can deploy your machine learning models on this using TensorFlow or RT. And then we have a Google Edge TPU. So basically it is a tensor processing unit, where basically these two devices are predominantly used for the deploying machine learning models. So where we are going with the edge computing, we have seen the edge computing, right? How the edge computing is going to going to change the AI world. So already we are experiencing it. So today every processing happens with the cloud, right? So everything you connect, your devices connect to the cloud data center, and then you send the data there, we do the processing. And currently we started doing is the example, as I told you, right? The mobile phones, right? The Google keyboard. So what we do is that we do like the way I type, right? The words that I type on my keyboard is entirely might not be same as you, right? So essentially we all use a text pad, but every one of us are different, right? How do you capture it? So the thing is that whatever the like what happens is that in my phone, it will first create the local model, and then the data what it has seen, right? The new words what I have typed and all those things, it would actually go to the global one, and then there it would actually percolate it is averaged out to all the other users. So from the local data, you from the local you actually you build a local data to every device, and then the local data is averaged out, and then you build a global model, and then you send once again across the devices. So this is how the federated learning is working, and that's what we are actually seeing. So we are giving the intelligence to the end devices. This is true not only even in the computing scenario, we are seeing the same trend even in networking. So with SDN and all those things. So what are the advantages that we are going to see with the edge AI? So basically, artificial intelligence is necessary to fully unlock the potential data. Why? See, without AI, right? So how we are going to process the data that is generated? Typically, like 135 zettabytes of data, right? So, and without the cloud and AI, it is literally impossible to do the crunching, right? So for example, if we take let us take a very simple example of our shopping patterns in one of the Amazon or Flipkart, right? So over 2 or 3 years, we have predominantly logged in, and then we have searched for different items, and few of them we have bought. So the browsing data itself pertaining to us itself is a bigger one, right? And then compare about the number of users that they see, right? So typically the data is humongous. How do they actually come up, process it, and then make recommendations? So one of the thing that we see potential is with the AI and the edge, right? So as I told that the generating the humongous data at the same time giving an ability to process at the edge location. This provides the novel application scenarios, and not only that, the more see most of the edge devices are at with the people, right? So our mobile phone is one simple example of an edge device. It can do a lot of processing. We will see what are the training models that we have very shortly, right? So if you see here, right, so most of the when we talk about the democratization, we are taking the AI to the more and more people, right? For example, already the Gmail has done it, right? So we have all the recommendations most of the time when we actually nowadays when we want to interact with any company, right? First level support, second level support. The first level support is nowadays more or less like through chatbots, right? So even the banks like HDFC has their chatbots to help us to for the mundane task, right? We don't require a person to call and then do that, right? Even the Swiggy does that, and it is a cost effective and self-contained, right? And then we do have a different AI engineering level. So either at the level 0, we have a training and inference on the edge, on the cloud, and then you have a edge and cloud co-inference where you do inference with the help of cloud and the edge, and then you do the in-edge co-inference, and then on-device inference, and then you do the uh, cloud edge co-training, and then everything you do it in the edge, right? And then you do it on device. So here if you see, right, the first tier would be the device, and then the second tier is edge, and the third tier is cloud, right? The more you do it on the devices, the amount of data that you send to the cloud reduces. So these are the undergoing typical areas of research, especially with the edge AI. So these are the training architectures we have. So one is a centralized one, decentralized, and hybrid. So when we talk about the centralized, typically the training happens only at the cloud, right? All the data from mobile or different devices would send to the cloud, and there we do that. And then in decentralized, each one would send it, right? And in hybrid, in decentralized, each one would do the training by itself by looking at some others data, right? So and then with the hybrid, you do it both at the edge and both at the cloud. Okay, so generally the KPIs would be the training loss, right? How well my training model fits the training data. Convergence is nothing but how fast all the model would actually converge to the consensus. And then privacy, and the communication cost is nothing but the network bandwidth that I'm used, and the latency, right? What is the processing time that we actually generally see, and then finally the energy efficiency, right? These are the AI inference models, right? You have an edge server. You do everything in the edge server. You do with device based. You have your model on the edge, and you do inference on device, and then you do partial. You have a partial model in the edge, and then you have a partial model on device, and then you have partial model across the edge and cloud, and you do the inference on device. These are the four edge AI inference models. And one thing that I wanted to let you know was like how the 5G is going to change the landscape of edge AI, because the see, at any point of time, see, till now, right? So we have already seen the amount of speed that we are getting with the 4G compared to our 2G, right? So a decade back, we had our 2G. So basically, when when we were connecting through internet, right? It was using GPRS edge, right? So if you see on the signal antennas on the signal that was displayed on the user interface, you would see E, small e, right? So instead of 4G, now 4G is common with E. It would take a lot of time to just download a just to open a website, right? So generally we had a browsers like Opera, which were caching and all those things, right? So the speed was very limited, similar to what we had in the modem area, right? Modem era, right? 56 kbps modem era. So the broadband actually revolutionized the internet landscape, especially for the servers and desktops, right? The same thing 5G is going to do that. Already we are seeing, right? So nowadays, generally for watching movie, right, we actually use our mobiles because it's 4G, right? Most of the time, now 4G has become the default, right? So and we are seeing the 5G roll out, right? So probably we already our answers are ready, but probably this year and the next year we might see a real deployments in India, but there are deployments in 5G. So the 5G is the one which is going to change, is a game changer. So typically what it has is the same thing, right? You have a radio access network, cellular network, and then internet. Whenever, so these are the towers, mobile towers, right? So this is actually a part of backhaul network, and all our user devices, like nothing but our mobiles, right? These are all connected through our towers, and these towers are part of backhaul network, and then this would be connected to the mobile core, and it's your mobile core which is actually connected to the internet. So this is a fundamental architecture of 5G. Typical, it's not only 5G, it's a typical NEG we talk about nowadays. So what the 5G does, it actually supports for massive Internet of Things, massive critical control, and mobile broadband, right? You have better band data, right? And then you have in terms of battery usage and the latency, this is actually really good. But the thing is, where we are actually trying to reach. So these are the like, for example, critical control, right? So ultra low latency and all those things. For example, you can use 5G for robotic surgery also, right? Where the latency requirement is really less, right? So you know, when a doctor who is sitting in a remote location wants to perform a robotic surgery, right? If the latency is too high, what happens is that it will not be any sync, right? Whatever that the doctor is trying to do. So how 5G is going to complement works with Edge AI? So this is a typical 4G that what we are seeing here, and this is a courtesy to IBM. So they are doing a lot of work on this. So generally, what happens is that we have a 100 millisecond latency to the internet servers. So how? So basically, whatever the data we are actually sent through 4G, right? It will go to the cell tower, cell antenna, through which it will go to the cell tower, and then packet core, APC, and then it will connect to internet, and then it will go to the cloud. So typically this would actually take me around 100 milliseconds. And then if you take a typical 5G network, right, what happens is that you would achieve 5 millisecond latency, because so once you have a cell tower, it will not directly go to the edge, okay? Sorry, it will not directly go to the cloud. So what it does is it will have a mobile edge cloud, and then it will go to the packet core, and then what happens is that enterprise edge server. So the edge would actually going to reduce the latency considerably. So if you see the timeline, right? So as I told you, right, it was in 2G, we were getting the 64 kbps, and with the 4G, we were getting around the 8 to 80 mbps, and with 5G, we are expecting at least 50 times bandwidth compared to the 4G. So I would suggest you guys to join this channel, and not only that, we are exploring. So already we have a like Professor Satyan actually gave a very good introduction about the microwatt. So we are actually from the Open Power Foundation, we are working on the curriculum of SOC design for those kind of like for the edge and edge devices like microwatt. Now we are actually working on moving the curriculum for the edge AI to enterprise AI. So that's another ball game altogether. So we are currently working on that. Anyone who is actually very interested, so please go and subscribe to this Open Power AI Virtual University. So any questions?
Thank you, Professor Abhinandan, for the wonderful talk on the AGI.